correct topic for chapter 5 is just making sure we feel comfortable with fractions, basically putting them in our calculator, having them do the math, whether it's reducing, adding, whatever it may be. Venn diagrams, which is something that some of you may have seen, or it might be the first time you've seen them. And then inequalities, which we've all probably seen, but we want to make sure we feel comfortable with not only the inequality symbol, but how to graph them on number lines and use interval notation, okay? So it says, on number 1 and 2, we're going to write the fraction in simplest form and as an equivalent decimal rounded to the nearest thousands and as a percent. So it's all kind of the stuff we've done before other than reducing this. So in your calculator, what you're going to do is realize that anytime we want to do anything with fractions, the division bar is just that, okay? So in your calculator, you do 8 divided by 56, and then go to math button, which is right here under alpha. And if you hit math, fractions are the very first thing isolated. So you hit enter, and it'll give you 1/7, okay? So on these two guys, they're going to look for 3 answers. They want the reduced fraction. So we'll say this is equivalent to 1/7. But they also want a decimal rounded to the nearest thousandths, and so that's 3 decimals. So we'll do 8 divided by 56, and so that will be 0.143. I'm going to put squiggly brackets there, guys, because the squiggly, or not brackets, squiggly equal sign just means approximately. So 1/7 is exactly 8 over 56, so I can put an equal sign there. But anytime you put it in decimal form and you have to round, it's not exact, right? So this just means it's approximately 0.143. Does that look okay? And then the last thing is, they want us to turn it to a percent. Do you remember what you need to do to change a decimal to a percent? Times it by 100, move the decimal over 2 spots. And what's nice is how they have us round it to the nearest thousandth here. When we multiply it by 100, we'll be rounded to the nearest tenth of a percent. So it'll all work out. So don't round until the end, right? So we'll have 14.3, which is equivalent to 14.3%. Okay, so those are the 3 answers they're going to look for. 10/13, some of you might already know, that's actually already reduced because 10 breaks down to 2 and 5, but 13 doesn't break down to anything. But say you don't know, you put it in your calculator just to double check, and you do 10 divided by 13, math frac, and what does it give you? 10/13, all right? So that is already in its simplest form. I'm going to go ahead and rewrite it, though, so we know it's part of our answer. Go ahead and divide 10 by 13 to get the decimal equivalent. Rounded to 3 decimals will be 0.769. So I'm going to do a little squiggly equal sign, 0.769. And then, of course, multiplying by 100, guys, it's just going to move that decimal over 2 spots. So that is 76.9%. And hopefully you, as we do this, guys, probability, we do a lot of like drawing cards and rolling dice and stuff like that. When we do this, kind of keep in mind, like 1/7, like if that was a pizza and only 1/7 was left, not a whole lot of it was left, right? So it makes sense that it goes with 14%. But 10 out of 13 slices left of the pizza, that's most of your pizza. And that's, so kind of just think proportionate equal to 100%, like where we are to make sure your answers are correct. All right, so then we're going to actually get into, I think it's section 5.2, where we're going to start adding fractions. And the one thing about adding fractions, if you were doing it by hand, you need a common denominator, and it can get kind of lengthy. You get the common denominator, you convert the numerators, all that stuff. We don't have to do that. We can just put it in our calculator, hit math frac, and it'll give us that reduced answer. But again, notice that it wants it all in 3 ways, right? They want us to come up with the answer in simplest form, but also as a decimal and also as a percent. So I put it in parentheses. I don't know if you need to, but I do. So I do parentheses 1 divided by 9. So it kind of knows that that's my fraction. Plus parentheses 1 divided by 9, like that. And if you hit math fraction, it will give you your answer, 2/9. That's one that we could just do in our head, right? We have the LCD of 9. What's 1 plus 1? 2. So 2/9 is going to be our reduced fraction. But if we need that as a decimal, we'll just take 2 divided by 9 in our calculator, and we'll get 0.2 repeating. So I'm going to do the squiggly equal sign, which means approximately. Rounding to the nearest thousandths is 3 decimal places. So it'll be 3 2s. And then again, just move that decimal over 2 spots or multiply by 100 to get the equivalent percent of 22.2%. And like I said, that one's not horrible. Actually, I could have done all that in my head, because I know 1 plus 1 is 2, so 2 ninths. And remember, anytime you divide by 9, guys, it's just that number repeated. So 1 ninth would be 0.1111, 7 ninths would be 0.777. All right, this one is where you'd have to find the LCD. What's the smallest number that 20 and 16 go into? But we don't have to worry about that. We can let our calculator do it. So we'll do parenthesis 1 divided by 20, parenthesis, plus parenthesis 1 divided by 16. And just hit math fraction, and it'll give you your answer there, 9/80ths. Which is not very big, but 1/20th and 1/16th are both really, really small fractions, so when we add them, we're still not going to get a very big answer. To get them as a decimal, just do 9 divided by 80, and you get 0.113 if we're going to round to the nearest thousandth. And again, to move it over 2 spots, you multiply by 100, you get 11.3%. And like I said, I don't have the answer key with me, guys, so make sure that you're getting the same thing I am. Does everything look okay? And I said 9/80ths isn't that big. It's a little bit more than 10%, and that's exactly what my percentage proved to me. All right, so the next part is the Venn diagram part, all right? So the Venn diagram part is a way to show two sets of things, A and B, and what they share and what they don't share, okay? So what we want to make a note of on our notes right here is this symbol here is union. And union means what's in both sets, A plus B, or A or B technically. So it's like together / total, okay? So anytime you see the union, you want to know, okay, what do we have all together? Or what do we have total in these sets? And what goes along with the union is an upside down U that looks like the arch. And that is intersection. And intersection is exactly what you think it is. What's happening at an intersection? Two roads are crossing and they're meeting, right? So intersection is what they share, okay? So this is the shared stuff. So looking at, and this is just kind of notes because on this one we're just doing union, but on your homework, on your worksheet, they might throw an intersection at you as well. So I want you to notice both. So on this one it says, shade the portion of the diagram that represents A union B. Well, what did A union B? It means together or total. So we want to shade A and B total. So what would we be shading? The whole thing but the rectangle, right? Like the MasterCard symbol inside our credit card, right? So we want to shade A and B. I know this doesn't ask it, but I'm pretty sure the worksheet I'll give you in like 5 minutes will ask it. If they asked you to shade the the intersection, what would we shade if we're shading the intersection? This middle part, like the little football part in the middle, is what they both would have. The reason why this is important is because here in a second you'll see with these numbers, we're going to start talking about probability, and sometimes when it comes to drawing a card, they might care about you drawing a red card or a queen, and that overlaps, right? There's red queen, so we kind of have to think about this overlap or non-overlapping idea. All right, so 6 and 7 are taking this idea but not giving you a visual. They're just having you look at the sets, all right? So it says if A is the set of numbers 19, 20, 21, 24, and B is the set of numbers 17, 19, 20, and 22, list the elements in A intersect B. So we're going to make a new set. It's called A intersect B, and it's going to have squiggly brackets. And in this set, we're going to list all the numbers that A and B share, because intersection means shared. So what numbers do A and B both have? 19 and 20. Do you guys agree? So they both have 19 and 20. So this intersection set is made up of the two elements 19 and 20, okay? So notice the set, they call it with a big capital letter, and they say A equals, and they have squiggly brackets with the elements inside of it, right? So when we come up with our new set, it's a new set. So we want to make sure we write them in capital letters, equals, and put them in squiggly brackets, okay? Let's look at this one. Down here it says if A is the set of numbers 59, 60, 61, 64, and B is the set of numbers 57, 59, 60, and 62, what are the elements that are in A union B? Well, A union B is all of them together, but you don't need a repeat. What do I mean by that? Do you notice that they both have a 60 in there? We don't need to list 60 twice, right? So I just say, okay, well, it needs A for sure. So I'm going to throw all the elements of A in there, right? We need A and B, so it needs A for sure. So I'm going to write all the elements of A. Is that okay? But we want A and B together. So I'm going to go on to B, and I'm going to list any additional elements that I haven't listed already, okay? So you go to B, and he has 57. Have we mentioned 57 yet? Nope. So we're going to add 57. He has 59, but notice A had 59 as well, so we don't need to repeat 59. And the same with 60. 60 was in both, so we don't need to repeat it. What about 62, though? Have we listed 62 yet? No, so we're going to add that in. So this is like the total. So the intersect is what they share. It's like if you were to draw this, you could draw this as a Venn diagram. You don't have to, guys, but if you wanted to draw this as a Venn diagram, you would have A and B, but who would be in the middle? 19 and 20, right? But A would also have 21 and 24, and B would also have 17 and 22. There's a visual of it. You guys see it? So there's a set B, all of his numbers. There's a set A, all of his numbers, but what do they share? That 19 and 20 in the middle. We could do the same thing with them, and 59 and 60 would be in the middle there. Are there any questions on the front page? You guys good? So the back page is just getting us comfortable with inequalities. And so I went through, it's not an exhaustive list, it's just the list that came to my head, like I just came up with it. All the different words that mean certain things. What do I mean by that? If we have this is called the less than symbols, but when you get into your stats class, they're not going to be using the symbols, they're going to be using words. Find the probability that it's less than, fewer than, no greater than. They're going to use all these different words. And so I have all that listed. So the key thing here, the difference between here and here is that line in the middle or down at the bottom. Do you guys remember what that line at the bottom means? It's equal, so it means it's included as well. So here, this is called a strict inequality. It has to be exactly less than, below than, and fewer, okay? But then notice like all these are kind of the same ones, but then you have that amount of equal added to it, right? So no more than means it could be this or fewer. And then less than or equal to means it could be this or less than, right? Does not exceed, not above, at most, not greater than. So again, this is not an exhaustive list. There's more out there. I just tried to come up with all the other ones. And then this is just the flip-flop. This is the greater than symbol, and this is the greater than or equal to symbol. So this is strict greater than, means you have to be more than it. Greater than, above, more than, exceeding. And then greater than or equal to means it could be that or higher. All right, so that's no less than, greater than or equal to, at least is a common one, okay? Not under, no fewer than. All right, so let's do these ones at the bottom here, 8 and 9. So they just want us to come up with the correct inequality symbol. So how I do it is I pull the numbers and I write the numbers on the line and I leave a gap for the symbol we're supposed to use, okay? So what do we have? We have 14 is greater than 2. So what two numbers are we dealing with? 14 and 2. And then greater than, is it equal? No, they just want greater than. So it's going to be that strict inequality. And remember, Pac-Man, the alligator, however you want to think about it, he's greedy and he wants to eat the biggest one. So of 14 and 2, which one's the bigger number? 14. So Pac-Man or the alligator wants to eat 14. And that is the greater than symbol. You're like, Molly, I can look up here and this is greater than. But you might not always have this. So I'm trying to kind of make you think, okay, you always want to have the mouth open towards the bigger number. All right, let's look at 9. 13 is less than or equal to 15. So we have 13 and we have 15. Of these two, which one's bigger? The 15, so we want to eat him. But we want to pay attention to, it says less than or equal to, so what do I need to throw over here? That equality bar at the bottom, okay? And you just make sure you wrote two true statements, right? 14 is greater than 2. 13 is less than or equal to 15. It's not equal to, but it is less than, so it meets that part. All right, so the last concept is, now that we kind of have an idea of inequalities, can we shade which direction we're going, okay? And then can we write it in interval notation? Interval notation uses parentheses or brackets from left to right. You guys might have, I know growing up I didn't use parentheses and brackets. I used open circles, closed circles. Did anybody use open circle, closed? So open circle means like the strict less than or the strict greater than, you weren't including it. So for purposes of this class, an open circle is actually a parenthesis, okay? And then a closed circle means you're going to go to that number, but you can include it, right? And for purposes of this class, the closed circle is a bracket, meaning a square parenthesis, all right? So we have x is less than -4. So we go to -4, and we want to say, okay, well, what values are less than -4? To the left or to the right? To the left. So I'm going to shade all the values that are leading up to -4. Do I want to include -4, though? No. So I'm going to have a parenthesis. So we'll make note of that. I don't know if you want to write it somewhere, guys. Parentheses are for open circles. Brackets are for closed circles. Oops, you can't see it. Okay? Just in case you grew up using one or the other, okay? So if you need to use an open circle, you can't really just use a parenthesis. And usually that parenthesis opens in the direction of which you've shaded, right? So if you look at number 10 down here, guys, we're shading to the left because we want to shade all the values less than -4. So -5, -6, -7, those are all smaller than -4. So I'm shading to the left, and notice my parenthesis is opening that direction, all right? This one, I think these are the easiest ones because it's an x value that's just strictly between two numbers. So you don't have to think, am I shading to the left, am I shading to the right? I'm shading in between, right? So -4, we're going to have him. Is he going to be a parenthesis or a bracket at -4? Parenthesis, because that's just a strict inequality. And at 0, is that going to be a bracket or parenthesis? Parenthesis. So we're just going to have two parentheses. One at -4 opening towards 0. One at 0 opening towards -4. And we're going to shade all the values in between. So this x is between these two numbers. That x is between two numbers. And I'm going to go back because I forgot that we're supposed to write it in inequality notation, interval notation. We'll go back and do that here in a second. All right, so 12, last one, guys. We want all x's that are greater than or equal to -5. So here's -5. What values are greater than -5? To the right, okay? Are we including -5? Yes. And so we're going to have a bracket, and we're going to face all the values that are greater than -5. So when it comes to interval notation, sometimes graphing it on a number line, even though they don't ask you to graph it on a number line, I think it helps you visually see the interval notation better than anything, okay? What do I mean by that? An interval notation always has a lower bound, like how low can you go? Oh, it's like limbo, low, baby, low. No, I think I've used that already before in here, okay? And then how high can you go? It's an upper bound, all right? You're going to use parentheses and brackets just like you did in your shading, okay? The only thing we haven't talked about yet is the idea of going on forever. What number represents going on forever? The infinity symbol, right? So if we're going on forever in the positive direction, it's a positive infinity. If we're going forever in the negative direction, it's just a negative infinity, all right? So looking at this one, we want all x values less than -4. So we're going low, 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 low. We're not stopping. So what's the lowest we go? Negative infinity. Do you ever hit infinity or negative infinity? No, because if you say you do, I go, well, add +1, and that's my infinity. You know, we can always add +1 to it. So since we never hit infinity, they always have a parenthesis, okay? So over here on the line, guys, we're going to say our lower bound, well, it's going off to the left forever, so our lower bound's technically negative infinity, comma. And then we come up to and stop where? What's our upper bound? -4. Are we including -4? Nope. So if you used a parenthesis here, you're going to use a parenthesis here, okay? So your graph will match your interval. So notice this was the upper bound, so he was on the far right side. We're shading to the left forever, so if you're going to go to the left forever, you're going to go to negative infinity. 11, again, I don't know why. I think you guys struggle with it more than I do. I like these ones where it's like obvious. What's my lower bound? What's my upper bound, right? How low do we go on this line? -4. How high do we go on this line? 0. Do we include either one? No. So we'll have a parenthesis for both. And you could have a parenthesis on one and a bracket on the other. So just know that they don't have to match. Like this could be less than or equal to there, and you could have a bracket on one side. All right, this next one, guys, how low do we go on this guy? -5. Are we including him, though? Yes. So since we had a bracket there, we're going to have a bracket here. And then how high are we going? Infinity, and it's positive infinity. We never hit them. So we have a parenthesis.